Okay. Uh, Yesterday when we talked about sample size, I wonder if you still remember. There are a few rules of thumb. For probability sampling or for non-probability sampling. Okay, rule of thumb number one, you calculate your sample size based on the number of your item. Rule of thumb number two, you calculate your sample size based on the number of your construct. Okay, there's another one. Okay, and that is you decide your sample size based on the analytical tool, the analytical technique that you use. Analytical tool, analytical technique that you use. Okay? In general, if you look at point number 3, in general, whenever you run factor analysis, more than 100 cases, more than 100 respondents are always preferable. Okay? You can argue why in your case it is less. Okay? And there will always be literature to support. But you have to make sure when you use that literature to support, your justification makes sense. Okay? Or in another situation, EFA, exploratory factor analysis, no matter how important it is, and I'm going to show you later, you can justify why you don't need it. Alright? For example, you have a target population of 200. You want to do EFA, exploratory factor analysis. After you do your EFA, you want to do your regression. Okay? You do your EFA because you want to know what are the factor structure. After you know what are the factor structure, you want to use this factor structure as your independent variables so that you can do regression. This is what we learned this afternoon. Now, if your target population is only 200, and if you use 100 for your EFA, exploratory factor analysis, you only have 100 left for your regression. And remember what I said yesterday, those who respond early are usually good respondents. You only have 100 left, and out of this 100, maybe 30 they will not do it for you. Maybe another 30 they will do it, but they will not do it accurately for you. You may end up throwing away their question. So 100 left, minus 30, you only have 40 respondents for your regression. So, in this situation, you have to ask yourself, is it necessary to run EFA? Is it necessary to run exploratory factor analysis? This is what SPSS does. What you will learn this Saturday and what you will learn next week in Dr. Jackie's class, we call it CFA, confirmatory factor analysis. Okay, confirmatory factor analysis. So, in your study, you have to ask, and I will explain later, do you need to do exploratory analysis? Or can you go straight into confirmatory factor analysis? Okay? Now, I want to do a bit of promotion, and that is what you're going to learn this Saturday, what you're going to learn next week. Smart PLS. Smart PLS runs factor analysis and regression together. Okay, together. Alright? The scenario that I gave you just now, if you only have 200 respondents, you need 100 for EFA, another 100 for regression. You need to do 2 times. Okay, and the respondents cannot be the same. Why? Because you do 2 times. But the good thing, the strength of SCM, structural equation modeling, and next week and this Saturday you will learn software called Smart PLS. What it does is, this software performs factor analysis and regression together, and therefore you don't have to split 100, 100. You just run together 120 people. Why? Because 30 they will not respond, 30 of them they will not do it correctly for you. So you collect 180, you throw away 30, you still have 150. You run everything together in one model. Okay. Now, having said that, it does not mean you are wasting your time this week to learn SPSS. Okay, because SPSS can do things which Smart PLS cannot do. For example, t-test, ANOVA, these are the things you have to do in SPSS. You have to learn data entry. Data entry can only be done in SPSS. You can do data entry in Excel. You cannot do data entry in Smart PLS. So it is still important to learn SPSS and to understand the mechanism behind the software. You have to understand how it works. So that when you use Smart PLS next week, hopefully things will become slightly easier. Okay, slightly easier. So I need to tell Jackie, I have done him a huge favor explaining all these fundamental things. So to prepare him, he is less patient than me. So all of you must be ready. Okay. So anyway, hopefully you will learn enough this week, not only for your research but also for something more advanced. Alright? Okay, sample size. In general, more than 100. Okay, you will, but in some cases, 100 may not be enough. In some cases, 60, 70 might be enough. Okay, so it will depend on a few things. Okay, it depends on the results. Factor analysis will give you a few tables, and these results are very important, okay, to make certain decisions. We will look into it later. Okay. Now, oops. Okay. These are the things we will do later, but right now you see the slide. It's easier for you to understand properly, and you can always refer to the slide later, because when we run the analysis later, I will have to mention this all the time. Okay? So these are the things we will do. Okay, correlation matrix. We will run KMO. Okay, we will run Bartlett test. We will look at anti-image. Okay, I will explain later. Method of extracting factors. We will use principal component. But I will show you another extracting factor, which is called axis factoring. And for some people who have used SPSS factor analysis before, you might be shocked with my explanation later. If you have not used before, then nothing shocking, because you learn this for the first time. Okay? So I don't know about Dr. Lishing, anyone else there. If you have used SPSS before, I will tell you why principal component is actually not the right choice. Okay, not the right choice. Most people use this, but this is actually not the right choice. Okay, people use this because this produces better results. Better in the sense that you can better in the sense, better not in the sense that the estimation is accurate. Better in the sense that it looks nicer and you can report that, okay, less problems so that you don't have to delete your item, okay. So principal component tends to produce better results than axis factory. If you read the book by Tabashnik and Fieldel, the true EFA, exploratory factor analysis, is not this. Okay, it's not this one. It is the one that I mentioned just now, and I will show you later. Okay, these are the things we will look at. Anti-image, why it must be more than 0.5. Okay, oops. Okay, oops. Okay, then we will look at communalities. Communalities is not AVE, but it is very similar to AVE. Okay, average variance expected. Okay, later on, when we look at the result, I will explain. Okay, and why it has to be more than 0.5, and what value you should have depends on what your sample size is. And that's why if you have a bigger sample size, this is more relaxed. If you have small sample size, this will be more stringent, very stringent. And that's where many people fail their factor analysis test. Okay? But what many people do, they purposely ignore this. They don't want to report this error. Okay? Because they know their results look bad. Better don't report it. Okay? Then we look at how many factor structure based on these criteria, eigenvalue criteria. Okay, so based on our normal practice, we always look at eigenvalue of more than 1. Again, I will show you later how it looks like. For those who have used SPSS factor analysis, again, it might be shocking to you if I tell you that this criteria is the poorest criteria. The better criteria is Scribble. The best criteria is to use Monte Carlo simulation test. This application is in folder number 9, which I have not sent to you, which I have not uploaded. I don't know if I need to do that. Okay? This is called parallel analysis. Okay? This is the better way to determine how many factors you actually have in your data. Again, this is all EFA, but at the end of the day, you might blame me. Why? Because you might not use EFA, you might not use EFA at all in your study. So that's why, apart from clicking, if you have been listening, no matter how much you understand, the explanation is very important, because this explanation is not only for EFA, it is also for CFA, for regression, or whatever. So all these are the things that you have to understand as a quantitative data analysis. Okay, because you cannot rely on the software too much. You click, and you don't know why you click, why you don't click. Alright, so the reasons behind are very important. Okay, A chloride criteria or number to be expected. Okay, factor analysis also allows you to tell the software, tell the tool how many factors you decide. Okay, so instead of letting the software decide how many factors your data have based on correlation, you can actually decide for the software. This sounds a good practice. This also sounds a bad practice. Bad practice because you force SPSS to lie. Okay? SPSS factor analysis based on these techniques tells you there are 5 factors. But when you look at these 5 factors, you don't know how to explain. So what you do is, you tell the software, I only want 3. I only want 3. So SPSS will run 3 factors for you. Okay? Then in your report, you report, and in your thesis, you report happily that factor analysis produces the result of 3 factors. In fact, you tell the software to do that. Okay? That is why factor analysis in SPSS is one of the most abused techniques in the world. This is not my word. This is something which authors say, and it is published in articles. Okay? I don't know if I put it in the folders. You can check. Maybe it is already in the folder. Abuse and use of factor analysis. Abuse. A-B in bracket use. Either you use or abuse. Okay? Factor analysis in SPSS. There are many things you can do. Okay? Even your data is super lousy, you can change something to make it work. Okay? And in your thesis, you don't say. You keep it quiet. You just say, you run SPSS, you run factor analysis, and the factor analysis gives you this answer in your report. Okay? So, just be careful if your examiner is someone who knows all this software, okay? Because you will be challenged with some difficult questions. Okay, we will look at this percentage of variance explained. Okay, we will look at rotation. Okay, we will look at rotation. Usually, most people use Verimax. Most people use Verimax. I will tell later why, in most cases, using Verimax is also wrong. Is also wrong. Okay? Okay, let's see the explanation. The explanation is already here. You assume your variables are not related. Okay? Now, let me tell you, attitude and intention. Are they 2 different variables? Okay? Okay, these are 2 different variables, right? Because remember, I mentioned earlier, they must be mutually exhaustive. They cannot be the same. If they are the same, then you only have 1 variable. They are different, so you can test the relationship, right? But my question now is, do you think they are so different until there is no overlap? Do you think they are so different until there is no overlap? Okay, so that is the issue. Even though they are distinct, even though they are 2 different constructs, 2 different concepts, what happens is, in real world situation, there will overlap something. There will be some overlapping part. They cannot overlap too much. If they overlap too much, then they are actually the same. But there will be some correlation. Okay, attitude and intention. There will be some correlation. And that's why tomorrow we will learn bivariate correlation. You will see that these variables, even though they are different constructs, they are actually correlated to a certain degree. Cannot too much. They are correlated to a certain degree. And this is why, if you use Verimax, because by default, SPSS factor analysis will give you Verimax. You did not make this assumption. The assumption is these 2 variables are not correlated. Okay? Recently, I had a paper published. I am one of the co-authors. This paper was not from me. It was from my friend. My job is just to polish. My job is just to make the story slightly better. My friend used this. Okay, used this. And for me, it is not correct. Okay? But this paper passed through editor. It was reviewed. Reviewers were happy with this. Reviewers comment something else, and eventually this paper was accepted for publication, and now this is already published. Okay, so Sometimes luck plays a role. Not everyone agrees with what everyone says. You can also disagree with what I mentioned, but what I'm trying to do is I try to tell you things based on explanation. You have to read yourself because these are the things which may change. There are things which may not change for a long time. There are things which may change after 1 year, after 2 years. Again, this is something which I told you last Friday. Okay, whatever I explained to you, maybe after 1 year, part of them are incorrect. Right? So as it is today, based on the ebook by Kawashik and Udell, okay, most of the time we should be using Promax. Okay, and if we use Promax, we should look at pattern matrix later. Alright? Iteration. Remember, factor analysis does not know theory. EFA, exploratory factor analysis, does not know theory. You as a researcher, you know what theory to use. Factor analysis as a software, as a technique, it does not know theory. What it does is, it runs correlation based on your data characteristics. It runs correlation based on your data characteristics. So, iteration allows the software to run exploratory factor analysis in order to find data which are correlated to one another. Okay? Eventually, it will converge. Then the software and then the technique will produce 4 factors, 5 factors, 6 factors. Okay? This is another thing which you can manipulate. How to manipulate? If your data is very poor, and I have used this type of data before, your data is very poor. By default, 25 iteration. After iteration is done, nothing is converged. Nothing. Why? Because the data is so poor, the technique that you use cannot find the factors, cannot come up with factors. So what you do is, you increase this number to 30, 40, 50, 60, 70, many rounds of iteration. Again, you torture the software, you torture the data until they tell you something. Okay? You torture the data, you do this until the data lies. Okay? So again, in your report, you won't say this. You won't say 25 iteration could not produce a result. Hence, the author decided to increase iteration from 25 to 100. The moment you do this, you are killing yourself. Because researchers who understand this, after reading this tells them that your data is super lousy. Okay, so these are the things you want to report. Again, this is how you use the software. Okay, loading significance, we will look into it later. This threshold is not really, you don't take it on face value. Okay, you don't take it on face value because again, there are reasons why 0.3, 0.4, 0.5, 0.7, 0.708. Okay. I will explain it. Okay, I think I'm not managing my time. Okay, 11:21. Because I told you we need a bit more time. Don't worry, when you look at the software later, when I talk about all this again, hopefully you will relate. Okay, that's why I have to show you this first. Okay, because factor analysis produces more tables than ANOVA computers. Okay, this is Monte Carlo. Sorry, could you excuse me for a while? Okay. Could you excuse me for a while? My kids are